Hi all, very happy evening to each one of you. I hope you got a class notification. I hope the audio is clear. Let me check it out in my mobile. Very happy evening to each one of you. Very interesting class we are going to discuss. Extremely very important topic we are going to discuss. Kindly reply it in the chat if everything is clear. We will start the class in another 1 minute. Who are all are live? Kindly ensure that you comment in the live chat. We are going to do a lot of extra sessions covering a lot of wonderful concepts every day, early in the morning and late in the evening, other than weekends. Think Without Ink is a special series. It is a special series. We are at session number 2. What we will do is, in each and every session, we will take up a concept and we will discuss thoroughly about that concept. In case if you are watching it live, kindly reply it. Shiva says everything is clear. Narendra says yes. Session number 2. Kindly sit in the class with a notebook and a pen. Kindly sit in the class with a notebook and a pen. Those who have not seen session number 1, because of some technical issues, I have kept the video in the video section. Go to your batch. The name of your batch is Anil Nair App Downloaded Students. Anil Nair Classes App Downloaded Students. All the students who downloaded the app, you are a part of this batch. This is your batch name. Anil Nair Classes App Downloaded Student. Go to the video section. In case if you are a student who has missed the session number 1, in case if you missed on Think Without Ink session, kindly go ahead and watch it. We have discussed some wonderful concepts related to HCF elimination method. How you can eliminate the answer options. By using divisibility rule concept. In session number 2, what we are going to discuss? We are going to discuss calendar repetition concept. Calendar repetition concept. If everything goes very smoothly, every day we will have a lot of extra sessions. Tomorrow, early in the morning, we will have another session from 6:15 to 7:30. We will have one more session 6:15 to 7:30, and late in the evening we will have one more session from 10:30 to 11:30. Every day these are some of the extra sessions which I planned for the students who downloaded our ANC app. You can watch this session. Each and every session we will take up a concept from a topic. We will discuss the shortcuts present in the topic. Everything it is clear, right? Shall we all start the class? Kindly reply it in the live chat box present in our app. If everything is clear, then we will see the class. At the beginning of the class, I will see the chart if there are any issues. Manoranjan says yes. Vivek says all clear. Any other students kindly reply. Shiva says we can start. Please write down the concept. Calendars. What we are going to discuss today in the late in the evening session? Repetition of the calendar concept. First we will write down key points. Then we will execute the key points. The first key point is a year is divided into leap year and a non-leap year. Year based on The number of days, it is divided into leap year and a non-leap year. What do you mean by a non-leap year? A non-leap year is an year which is never divisible by 4. A non-leap year is an year which is never divisible by 4. How to check whether an year is a leap year or not? What is the divisibility rule of 4? Divisibility rule of 4 is last 2 digits should be divisible by 4. If the last 2 digits are not divisible by 4, then the year is called a non-leap year. An year where the last 2 digits, we will write down that point. Year where the last 2 digits are not divisible by 4. If the last 2 digits are not divisible by 4, if the last 2 digits are not divisible by 4, then the year is called a leap year. Why we are doing only the last 2 digits? Suppose if I take a 3-digit number in a decimal system. Decimal system will have base 10. C is there in units place. B is there in tens place. A is there in hundreds place. Am I right? 100A plus 10B plus C. Listen carefully, sir. Very interesting way to understand why the divisibility rule of 4 is last 2 digits only should be divisible by 4. ABC in base 10. It is C is in units place. B is in tens place. A is in hundreds place. 100A plus 10B plus C. If the left hand side, if it is divisible by 4, if the left hand side is divisible by 4, 100A is divisible by 4. If 100A is divisible by 4, that means, example, suppose if I take an example, 28 equivalent to 16 plus 12. 28 equivalent to 16 plus 12. 28 is divisible by 4. 16 is divisible by 4. 12 should be divisible by 4. If the left hand side is divisible by 4, 100 is 4 into 25. That means this is also divisible by 4. This should be divisible by 4. This should be divisible by 4. What do you mean by 10B plus C? 10B plus C is nothing but the last 2 digits of a number. So what is the divisibility rule of 4? The last 2 digits should be divisible by 4. What do you mean by a non-leap year? An year which is never divisible by 4. What do you mean by never divisible by 4? Last 2 digits should never be divisible by 4. Last 2 digits should be never be divisible by 4. Example. Suppose if I take 2013, last 2 digits, 13 is never divisible by 4. So it is a non-leap year. It is a non-leap year. If we take our Independence Day, 1947. 47, 4 11s are 44, 4 12s are 48. It is a non-leap year. It is a non-leap year. I hope it is clear. Non-leap year is a year which is never divisible by 4. A leap year definition, there are 2 subconditions. There are 2 subconditions. If the year is a non-century, if the year is a non-century, if it is divisible by 4, if the year is a non-century, if it is divisible by 4, then it is a leap year. If it is a century, what do you mean by century? Century is defined as divisible by 100. What do you mean by divisible by 100? The last 2 digits are 0 zeros. The last 2 digits are 0 zeros. That means century is divisible by 100 and it is also divisible by 4. If it is a century, it should be divisible by 400. If it is a century, it should be divisible by 400. Very, very important key point, sir. Again, I am repeating this key point. A leap year is not necessarily an year which is divisible by 4. Yes, it is divisible by 4 if the given year is a non-century. How to determine whether it is a century or a non-century? Last 2 digits, if it is 0, 0, then it is a century. Century means 100, 200, 300, 400, 500. That means century is always always divisible by 100. It should be divisible by 100. It should be if a number is divisible by 2 and it is divisible by 3, it is divisible by 2 and 3, which is 6. If a number is divisible by 100 and it is also divisible by 4, that means a number is always divisible by 400. Number is always divisible by 400. Suppose if I take 1900, if I take 1900 last two digits are 00. That means it is a century. For a century to become a leap year, it should be divisible by 400. If I divide by 400, two zeros cancel. Is 19 divisible by 4? 19 is not divisible by 4. That means 1900 is a non-leap year. 1900 is a non-leap year. Are you all with me? Suppose if I take 2800, the last two digits are 00. Is it divisible by 400? Definitely yes. 00 cancel. 28 divided by 4, 7. Yes. That means 2800, it is a leap year. 2800, it is a leap year. I hope it is clear. Similarly, if I take 1768, it is a non-century. If it is a non-century, it should be divisible by 4. Last two digits is 68. 68 is divisible by 4. That means 1768, it is a leap year. 1768, it is a leap year. 2037. 37. Last two digits, it is 37. 37, is it divisible by 4? No. So, this is a non-leap year. This is a non-leap year. I hope the definition of a leap year and a non-leap year, it is crystal clear to you. I am repeating the most important key points. If a year is never divisible by 4, it is a non-leap year. But for it to be divisible by 4, it may be either century or a non-century. Non-century, it should be divisible by 4. Century means it is divisible by 100. Divisible by 100 and divisible by 4. That means it is divisible by which number? 400. It is divisible by 400. Definition. How to check whether a year is a leap year or a non-leap year. I hope the idea it is clear. I hope the idea it is clear. In today's class, we are going to discuss first traditional method, then the optimal way of solving the question without even putting pen. Very interesting concepts it is going to be. But before that, second point. Key point 1. Key point 1 talks about which one it is a leap year and which one it is a non-leap year. Key point 2. Key point 2. Listen carefully, sir. Key point 2. Now, there will be a difference in the number of days. A leap year will have 366 days. A leap year will have 366 days. There are 7 days in a week. There are 7 days in a week. So, for every week, suppose if it is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, 7 day. If today is Sunday, if I count it 1 from tomorrow, 7th day will be the Sunday. If today is Monday, 7th day from today, 1 Sunday, today is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. I hope it is clear. Monday, Tuesday. So that means if today is Sunday, from today 7th day, tomorrow 1, next day 2, next day 3, like that. 7th day will be Sunday. So because there are 7 days in a week, divided by 7. 7 into 52 weeks. 7 into 52 weeks. Plus extra 2 days. 752s are 364 plus 2. Very, very important key point. A leap year will always have 2 extra days. A leap year will always have 2 extra days. A leap year will always give you 2 extra days. Very, very important key point. If it is a non-leap year, a non-leap year will have 365 days. A non-leap year will have 365 days. 365 days will be 7 into 52 plus 1. 52 weeks will be over. Then it is extra one day. A non-leap year. A non-leap year will give you how many extra days? One extra day it will give you. Suppose if the given year is 2012, 2012 is a leap year. How many extra days it will give you? 2 extra days it will give you. Non-leap year will give you 1 extra day. Non-leap year will give you 1 extra day. Leap year will give you 2 extra days and a non-leap year will give you 1 extra day. Extremely important key point. Suppose if I take 100 years. If I take 100 years, assume from 0 to 100 I am taking 100 years. If I take 100, suppose if I am starting from 0, 4th year it is divisible by 4, 8th year 80 is divisible by 4, it is a non-century. 12 it is divisible by 4, 16 it is divisible by 4, 96 it is divisible by 4. Suppose if I take 100, 100 is a century. Century should be divisible by 400. Is 100 divisible by 400? No. How many leap years we got? 4 ones are 4, 4 twos are 8, 4 threes are 12, 4 24s are 96. That means in 100 years, how many leap years I will get? 24 leap years I will get. What are the 24? 4, 8, 12, 16, 20 and so on up to 96. 24 leap years are there. In 100 years, 24 leap years are there. Remaining will be 100 minus 24, 76. How many non-leap years are there? 76 non-leap years are there. Just now we discussed a leap year will give you how many extra days? 2 extra days. A non-leap year will give you how many extra days? 1 extra day. A leap year will give you extra 2 days. A non-leap year will give you extra 1 day. 48 plus 76. 124 days. Very, very important key points. 124 days. Because there are 7 days in a week. 124 divided by 7. What is the remainder? Let us see. 7 ones are 7, 54. 7 sevens are 49. 5 extra days. 5 extra days. 5 extra days. 5 extra days. 100 years will give you how many extra days? 5 extra days. Very, very important point. Make a note in your notebook. 100 years will give you 5 extra days. 100 years will give you 5 extra days. I hope you made a note of it. Then we will erase the slide. We will write down in the same key point. Key point 1 is how to check whether an year is a leap year or a non-leap year. So first we have checked whether the year is a non-leap year. Second key point is how many days are there in a leap year and a non-leap year. Leap year has extra 2 days. Non-leap year has 1 extra days. After we checked the year, then we have taken a combination of 100 years. 100 years has how many extra days? 5 extra days. 100 years will give you 100 years will give you 5 extra days. I hope it is clear. Now key point 3. Very, very important key points. If you follow this, then tomorrow morning class will be much more easier for you. Key point number 3. What is key point number 3? Listen carefully. 100 years. 100 years will give you how many extra days? 5 extra days. In some textbooks, they also call it as odd days. They also call it as odd days. 100 years will have 5 extra days. 100 years will have 5 extra days. Sir, what do you mean by 5 extra days? Better listen carefully here. Suppose if it is January 1 till December 26th, the calendar it is over. 27, December 27, December 28, December 29, December 30, December 31. When I say 100 years, it is the 5 extra days. That also mean the last day of 100th year. the last day of 100th year. What will be the code value? The last day of 100th year, the code value will be 5. Both are same. 100 years will have 5 extra days. 100 years will have 5 extra days, also mean the last day of 100th year code value it is 5. Suppose 200 years. 100 years 5 extra days. 200 it is 10. Anything that you get greater than 7. Anything that you get greater than 7. Please take it, sir. Please take it. Hundred years will have 5 extra days. 200 years. Let us see. 200 years. 200 years. 100 years has 5 extra days. 200 will be into 2. So 5 into 2. 10. 10 extra days. Anything greater than 7, further divide it. Further divide it. Odd days or extra days, both are synonyms. 100 will be 5 extra days. 200 will be 10. 10 divided by 7. 10 divided by 7. 7 ones are 7. What is the remainder? 3. What is the remainder? 3. That means last day of 100th year, code value will be 5. Last day of 200th year, code value will be 3. Code value will be 3. Last day of 100th year, code value it is 5. Last day of 200th year, code value it is 3. Suppose if I take 300 years, 100 is 5. 300 will be 15 extra days. 15 extra days. Extra days and odd days, both are synonyms. So whenever you get greater than 7, further divide it. 15 divided by 7. 7 2s are 14. Remainder 1. That means last day of 300th year. Last day of 300th year, it is 1. Last day of 300th year, it is 1. Now, if I take 400 years, there is a difference between 100 years, 200 years, 300 years and 400 years. Even though all are century, all of these are century, then what is the difference? If you observe carefully, 100 years is a century which is never divisible by 400. 200 is a century which is never divisible by 400. 300 years is a century which is never divisible by 400. 400 is a century which is divisible by 400. That means 400th year, it is a leap year. It is a non-leap year. 300th year. 200th year, it is a non-leap year. 100th year, it is a non-leap year. Are you all with me? So, leap year has 366 days. Non-leap year has 365 days. 365 days. That means extra 100 it is 5. 400 will be 20. There will be extra 1 it will come. Why this extra 1 will come? 100 years, 200 years, 300 years. 100 is not divisible by 400. Not a leap year. 200 is not divisible by 400. Not a leap year. 300 is not divisible by 400. It is not a leap year. 400 is divisible by 400. That means it is a leap year. Leap year has 366 days. So non-leap year has 365 days. Extra 1 will come. So these 21 extra days. It is 21 extra days. 21 divided by 7. Anything greater than 7, further divide it. 21 divided by 7. 7 3s are 21. What is the remainder? 0. That means last day of 100th year code value it is 5. Last day of 200th year code value it is 3. Last day of 300th year code value it is 1. Last day of 400th year code value it is 0. I hope it is clear. You don't need to mug it up. Go very systematically. Leap year has extra 2 days. Non-leap year has extra 1 day. Then we have taken 100 leap years. Don't do a mistake of taking 25 leap years and 75 non-leap years. Remember, 100 is a century. Century should be divisible by 400 to become a leap year. So 24 leap years only will be there and 70 76 non-leap years it will be there. 100 we got 5 extra days. 5 extra days means December 26th calendar is over. 27, 28, 29, 30, 31. December 31st, the last day code value it will be 5. 200th year, last day code value it is 3. 300th year, code value it is 1. 400th year it is 0. Suppose if the question is 1300 years, 1300 years, how many extra days are there in 1300 years? 400 years it is forming perfectly divisible by 0. So take a multiple of 400. 3 into 400 plus 100. 3 into 400 it is 0. 0 into anything 0. 0 plus 100 5. So 1300 years. How many extra days will be there? 5 extra days will be there. After 400 you take any number, the cyclicity will be 4. It will come back to 5310. It will come back to 5310. For example, if I take 1300 years, 3 into 400 plus 100. 400 it is 0. 0 into anything 0. 100 it is 5 odd days. 0 plus 5 extra days it is 5 extra days. Suppose if I take 3000th year, 3000 years. 3000 years will be 7 into 400 plus 200. 400 code value it is 0. 200 code value it is 3. So 0 plus 3, answer will be 3. I hope the idea it is clear. After 400, if I take any centuries, 600 is 400 plus 12, 200. 1700 is 4 into 400 plus 100. 2900 is 7 into 400 plus 100. 3600 is 9 into 400. I hope it is clear. 100 years the code value it is 5. 200 years the code value it is 3. 300 years the code value it is 1. 400th year, the same calendar after 400 it gets repeated. For me very important is this key point. 5310. What is the significance of it? I hope key point 2 is crystal clear to you. Key point 1, it talks about how many extra days are there in a leap year and a non-leap year. In key point 2, 100 years, 200 years, 300 years, 400 years, and therefore so on and so forth. Any century, how much it will be. Is the idea clear? Now, if you see here, another very, very important key point. What is the significance of this one? What is this we got? 100 years. What is the code value we got? Last day of 100 years will have 5 extra days, or last year of 100th year. Last day of 100th year, the code value will be 5. 100 years it is 5. 200 years it is 3. 200 years it is 3. 300 years. 300 years. The code value it is 1. 400 years, the code value it is 0. 400 years, the code value it is 0. 400 years, the code value it is 0. 100 years 5, 200 years 3, 300 years 1, 400 years 0. What is the meaning of this line? Meaning is there are 7 days in a week. Sunday it is 0. Monday it is 1. Tuesday it is 3, 2. Wednesday it is 3. Thursday it is 4. Friday it will be 5. Are you all with me? Friday it is 5. And Saturday it will be 6. Sunday 0, Monday 1, Tuesday 2, Wednesday 3, Thursday 4, Friday 5, Saturday 6. 100 years will have 5 extra days. Our last year of 100 years, it will have code value 5. 5 is Friday. Last day of 100th year 5, Friday possible. 200 years it is 3. 3 means Wednesday. Last day of 200th year, code value it is Wednesday possible. 300 years it is 1. 1 is Monday, it is possible. Monday possible. Friday possible. Wednesday possible. Zero means Sunday possible. Sunday possible, Monday possible, Wednesday possible, Friday possible. And 5310 only gets repeated after 400. Very important key point. Last day of any century, last day of any century can never be, very important, sir. Last day of any century can never be Tuesday, Thursday and Saturday. Tuesday, Thursday and Saturday. Very important key points, sir. Tuesday, Thursday and Saturday. You take any century last day can never be Tuesday, Thursday and Saturday. Any century, you take 2000, you take 3000, you take 3800, 4500. The last day of any century can never be Tuesday, Thursday and Saturday. George in 15th century has given a calendar which is Gregorian calendar. In Gregorian calendar, Sunday will be the first day of the week and the code value that is assigned is 0. Sunday 0, Monday 1, Tuesday 2, Wednesday 3, Thursday 4, Friday 5 and Saturday 6. Are you all with me? That means if I divide a number by 4, what are all the possibilities? Either it will be perfectly divisible by 0, perfectly divisible, then only the remainder 0. Now, then it gives a remainder 1, then it gives a remainder 2, then it gives a remainder 3, then it gives a remainder 3. If n is a non-century, if it is perfectly divisible by 4, then it is a leap year. Then it is a non-leap year. This is the definition that holds good when n is a non-century. When n is a non-century. If it is a century, it should be divisible by 400. If it is a century, it should be divisible by 400. I hope the idea it is clear. Till here, if you got any doubts, kindly ask me. You got any doubts? I am looking at the chat box. You can ask me if it is clear to you. Everything clear, right? Slowly, steadily, from the basics to the highest level of calendars, I am going to discuss. We will discuss everything in detail. To all the viewers who are watching these free live classes only on app, these classes will not happen on YouTube because there was a technical error in session number 1. Session number 1 we uploaded it. Prasanna says it is clear. Manoranjan says it is perfectly clear till now. Any doubts, kindly put it in the chat. These are an exclusive sessions for the students. Anyway, there will be an special enrolled students. Classes will happen and most of my enrolled students knows that we will have a Saturday and Sunday enrolled special classes on the digital board. Apart from giving you the promised number of hours, I am ready to work early in the morning and late in the evening to help you learn more and more concepts. I firmly believe that the more the time you spent with me in the live classes, learning lot of concepts from my 15 years experience, the more and more confident you will feel. Everybody clear, right? It is for a non-century. Now what we'll do is, last day of any century can never be. Now look at this question. Look at this question. What is the minimum number of years? What is the minimum number of years after which the calendar will repeat? All are non-century. Can you see? Century means it should be divisible by 100. Last two digits will be 0. Now if you see, 16 is divisible by 4. That means the given year is a leap year. 17. 4 4s are 16. Remainder 1. That means it is of the form 4x plus 1. It is of the form 4x plus 1. 18. 4 fours are 16 plus 2. It is of the form 4x plus 2. First of all, what is the definition that we discussed? If n is a non-century, if it is divisible by 4, it should give remainder 0, 1, 2, 3. 0 means perfectly divisible by 4, it is a leap year. Otherwise, it can give remainder 1, remainder 2 and remainder 3. It is 19. 19 is 4 into 4, 16 plus 3. 96. 4 into 24. Are you all with me? All the forms which we got. Divisible by 4 we got it. When divided by 4, it gives a remainder 1, it gives a remainder 2, it gives a remainder 3. When you divide a number by 4, only 4 reminders you will get. 0, 1, 2, 3. I told you, if you divide a number by 3, you will get 3 reminders 0, 1, 2. Similarly, if you divide a number by x, you will get x reminders, and the reminders are from 0 to x minus 1. 0 to x minus 1. 97 is 4 into 24 plus 1. How? When the calendar, these 4 into 24 plus 2. So all the forms which we will do it. All the forms which we are going to do it. What will be the minimum number of years? Listen carefully. First I will do traditional method, then I will tell you a shortcut. Calendar repetition concept. Calendar repetition concept. At the end of the class, you will be able to understand this and solve these questions in probably less than 30 seconds. First we will do a traditional method. Question. The calendar for 2017, the calendar for 2017 will be same for which next immediate year? Which next? The calendar for 2017 will be same for which next immediate year? Very, very easy concept. First, immediate year. This is the question. First we are doing, when a number is divided by 4, remainder 1. Listen carefully, sir. Listen carefully. Traditional method. First we will discuss traditional method, then I will discuss optimal method. Traditional method. Traditional method. Let us see what is this traditional method. One is traditional method, another is shortcut method. Another is shortcut method. Once we understand traditional method, from there we can derive this shortcut method. The next thing is, what are the concepts that we used to solve this problem? The concept is, a leap year will have extra 2 days. A leap year will have extra 2 days. A leap year has extra 2 days. And a non-leap year has extra 1 day. A non-leap year has extra 1 day. And a leap year has extra 2 days. This is something which we discussed at the beginning, because we are going to use this concept in the traditional method. How to determine whether a year is a leap year or non-leap year? The last 2 digits, if it is divisible by 4, and it is a non-century, it is a leap year. If the last 2 digits are not divisible by 4, then it is a non-leap year. Traditional method. 2017. This 2017 is a non-leap year. Non-leap year will give you extra 1 day. 2018, it is a non-leap year. 18 is not divisible by 4. It will also give you extra 1 day. 2019, it is a non-leap year, so extra 1 day. Hey, 2020, last 2 digits are divisible by 4, so it will give you extra 2 days. 2021 is not divisible by 4, extra 1 day. 2022, it is not divisible by 4, extra 1 day. There are 7 days in a week. Start from the year which is given in the question. Either take +1 or +2. Take +1 if the year is a non-leap year. If the year is a leap year, take +2. If the year is a leap year, take +2. Why it is +2? A leap year has 366 days. 7 into 52 plus 2. 7 into 52 plus 2. I hope the idea it is clear. So 1, 2, 3, 5, 6, 7. Stop it here. That means calendar will be same. So what is 7? Suppose if today is Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Saturday, Sunday. If today is Sunday, if I consider Sunday as 1, Sunday as 1, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. Are you all with me? That means exactly there will be a gap between 7 days for the week to get repeated. 1 plus 1 plus 1, 3. 3 plus 2, 5. 5 plus 2, 7. So after 7 days, the calendar will get repeated. So answer for this question is 2023. Answer for this question is 2023. This is one way to solve. A leap year will have extra 2 days and a non-leap year will have 1 extra day. I used these both the concepts and then I solved it. Now listen carefully, sir. Please don't do any of this. It's a time waster. Anything which is a long method, we will not spend time. What is the concept that I discussed? N is a non-century. N is a non-century. N is a non-century. If N is divided by 4, if N is divided by 4, what are all the possibilities I will get? Either it gives a remainder 1, or it gives a remainder 2, or it gives a remainder 3, or it gives a remainder 0, are perfectly divisible. If take the year, divide by 4. If you get a remainder 1, the calendar will repeat after 6 years. The calendar will repeat after 6 years. If it gives a remainder 2 or a remainder 3, the calendar will repeat after 11 years. The calendar will repeat after 11 years. If it is perfectly divisible by 4, there are 3 conditions. First, 28 years, 12 years and 40 years. Very, very important, sir. So minimum number of years after which the calendar will be same. It all depends upon the nature of the numerical value. Very, very important concept. Take the year which is given in the question, divide by 4 and it gives a remainder 1. If it gives a remainder 1, the calendar will repeat after 6 years. Very, very important. Calendar will repeat after 6 years. If it gives a remainder 2, if it gives a remainder 2 or remainder 3, the calendar will repeat after 11 years. After 11 years. This, if time permits, we will discuss today or we will discuss early in the morning tomorrow. We will discuss when the year is a non-leap year. Non-leap year, what is the simple concept? 6 by 11. Remember very easily, World Trade Center collapse. It is 9 by 11. 9 by 11, it is the date when WTC got collapsed. USA emergency number is 911. USA emergency number is 911. Ulta of 9 is 6. Remember 6 by 11. 6 by 11. 6 by 11. This is the minimum number of years after which the calendar will get repeated. After which the calendar will get repeated if it is a non-leap year. If it is a non-leap year. Are you all with me? Sir, I get confused between both of this. Even if you get confused, logically if you think also, if you think logically also, you will get the answer. Suppose I take this same question. Sir, I get confused between 6 or 11 sometimes. There is no confusion. One more point, you will understand it clearly. The calendar for 2017, calendar for 2017 will be same for which next year? Calendar for 2017 will be same for next year. Sir, I am confused between whether should I take 6 or 11. Suppose one important key point, very, very important key point. Once you understand this key point, you will not do this answer. If the given year is a leap year, if the given year is a leap year, answer will be a leap year. Can a leap year calendar match with a non-leap year? No. If the given year is a leap year, answer also it will be a leap year. If the given year is a leap year, answer will be a leap year. If the given year is a non-leap year, if the given year is a non-leap year, what will be the answer? Answer will also be a non-leap year. Can a leap year calendar match with a non-leap year calendar? No. So, if the given year is a leap year, answer will also be a leap year. A leap year calendar will be same as another leap year. A non-leap year calendar will be same as another non-leap year. Sir, I am confused between 2023, which is plus 6, and I am confused between 2028 plus 9. I don't remember exactly whether it is 6 or 11. Then use this concept. 2017. What are the last two digits of 2017? 17. Is it a leap year or a non-leap year? The given question is a non-leap year. If the given question is a non-leap year, answer should be a leap year or a non-leap year? Answer should be a non-leap year. If I take second one, 2028. 28 is divisible by 4. So it is a leap year. Answer cannot be 2028. Are you all with me? Are you all with me, right, sir? Suppose whenever you are in confusion, sir, calendar for 1793. I am confused between 1799 or 1804. I don't know whether it is plus 6 or plus 11. I am confused. Use this logic. 1793, it is a non-leap year. If 1793, if it is a non-leap year, answer will also be a non-leap year. Answer will also be a non-leap year. 1804. Last two digits it is 04. It is divisible by 4. Can a leap year calendar match with non-leap year? No. Can a non-leap year calendar match with an leap year calendar? No. So whenever you are in doubt with the 6 or 11, use the concept of if the given year is a leap year, answer will be a leap year. If the given year is a non-leap year, answer will be a non-leap year. Is the idea clear? I hope the concept is very, very clear to you. Reminder 1, that means n. If it is 4p plus 1, calendar will repeat after 6 years. If it is divided by 4, it gives a remainder 2. It is plus 11 years. If it is divided by 4 and it gives a remainder 3, there also it is plus 11 years. This is when n is a non-leap year. N is a non-leap year. I hope the examples are very clear. Now we will solve. Non-leap year 2017. Answer is plus 6, 2023. 2018. See here. Sir, I am in doubt with the 6 or 11. If I take 6, 2024, it is a non-leap year and it is a leap year. Leap year matches with non-leap year? No. So it cannot be. Plus 11. 2029. Are you with me? That concept of if the given year is a leap year, answer will be a leap year. If the given year is a non-leap year, answer will be a non-leap year. 2019. It is plus 11. Answer is 2030. Answer will be 2030. 2097. It gives a reminder plus 6. Plus 6 is 2103. 2103. If I take plus 11, I will get 2108. 8 is not divisible. 8 is divisible by 4. A non-leap year calendar can never match with a leap year. 2098 plus 11. 2109 plus 11. It is 2109. Sir, I want to know exactly whether this answer is right or wrong. I did it for plus 6. I will also do for plus 11. 2019, it is a non-leap year. Non-leap year will have how many extra days? 1. 2020 will have leap year. It will have extra 2 days. 21, it is plus 1. 22, it is plus 1. 23, it is plus 1. 24, it is a leap year. plus 2. If you see here, 1 plus 2 3, 3 plus 1 4, 4 plus 1 5, 5 plus 1 6, 6 plus 2 8, 7 it crossed. What is the next multiple of 7? 14. So 25 it is plus 1, 26 it is plus 1, 27 it is plus 1, 28 it is plus 2, 29 it is plus 1. So 1 plus 2, 3, 4, 5, 6, 8, 9, 10, 11, 13, 14. 14 is a multiple of 7. So answer is 2030. Answer is 2030. I hope the idea it is clear. Calendar repetition. When the given year it is a non-century, and if it is not perfectly divisible by 4, then it is not a leap year. If it is a leap year, it should be divisible by 4. In repetition of calendars, the first part, we are checking what will happen if the given year is not divided by 4. If it gives a remainder 1, then it is plus 6. If it gives a remainder 2, it is plus 11. If it gives a remainder 3, it is plus 11. Remainder 1, it is plus 6. Remainder 2, remainder 3, it is plus 11. So in tomorrow early morning class, we will see the beautiful concept of 28 years, 12 years and 40 years. Generally the entire idea is calendar repetition 6, 11, 28, 12 and 40. Please take time to understand this concept. Tomorrow morning we will complete repetition of calendar. Then we will discuss Zeller's rule. Whatever I taught you till now, any doubts are there, kindly mention it in the chat. Right? If any doubts are there, I will take it up. Any doubts are there, I will take it up. Is the idea clear? Everybody kindly reply if every concept it is clear to you. I am sure you will not get any of these concepts. Remember, early in the morning and late in the evening, I decided to take out time from my personal life to help each one of you reach your dreams. Tomorrow morning 6:15 I will meet you again. We will complete and some other beautiful concepts in repetition of calendar. Thanks a lot for watching this class. Good night to each one of you. Thank you.